Let's start the Kafka here. I'm not sure I shall be able to complete because it will take a lot of time for Kafka itself. So I may give a brief understanding and also some details. May not go in depth here. As time permits, I will try to go in depth, but may not go for all the features. So we'll see what is Kafka. So Kafka, what I can say is the very first thing is Kafka is a distributed message queue. It's a message queue. That's all. But it is a distributed message queue. Or we can also say that it is a distributed persistent centralized repository. This is what I say about the Kafka. It is a distributed you can combine these two things also. It is a distributed persistent message queue, and also it is a distributed persistent centralized repository. If you come across normal message queue, we have a normal message queue. How usually a message queue looks like? Usually a message queue will have just in this fashion. We have a message queue. Some process P1 will be writing the data, some process P2 will be writing the data, some process P3 will be writing the data. You can have multiple processes writing the data to the or messages to the message queue. Some other process will be reading the message. Process 4 might be reading the message. Process 6, process 5 may be reading the message. Process 6 may be consuming the message. So this is a normal message queue here, but this message queue will be on a single system. This message queue will be on a single system. One more thing is this message queue is restricted or limited by the memory of that system. So you cannot scale this. If you keep on increasing, the number of messages increases, obviously the message queue will be full and we lose the messages. Sometimes there are message queues. We have JMS message queue. People use JMS where the data is stored in the file system. This is memory, I will say, RAM, I will say. Memory based message queues are there, which is stored in the RAM, or disk based. We have disk based message queue also, where data is stored in the disk, but again it is limited by the disk storage of that system. Again it is not scalable. So normal message queues cannot scale. So Kafka is a distributed message queue, hence it scales horizontally. You can have as many messages as you want. It can keep on increasing. That's what we talk about Kafka. This is a normal message queue. Kafka is a distributed message queue, meaning the data is distributed across the cluster of nodes. That is one reason why Kafka came into picture. This is one of the reason, because we can have a scalable message queue. One more reason is something like this. We have application 1. Let's say application 2 needs the data. Application 2 requires the data from application 1. So obviously there will be a connection established, an interface will be returned in both the ends so that one can send the data, the other can receive the data. Later on you add one more application, let's say application 3. Now application 2 also needs the data from application 3. Again you try to add one more interface on application 2 and an interface at application 3. Similarly, after some time you came up with one more application, application 4. Now let's say application 4 needed data from application 1. Again you have to have a interface for application 1 and a new interface at the application 4 so that it can receive the data from application 1. As and as we go on, more and more application come into picture. More and more application comes into picture. So some data may be required here, some data may be required here, somebody some data may be required here, some data may be required here, some data may be required here, some data may be required here. So if we see, as and as the number of applications grows on and as the data communication should happen between the applications, it gets messy. It gets messy, and the maintenance of such an architecture should be, maintenance of that kind of an architecture will be not so easy. It will be nightmare for the developers. So this is also one of the problem why Kafka came into picture. So lot of application wants to communicate with other applications. So they can do that with the distributed message queue, which here we call it as a Kafka here. Meaning that we have a Kafka here, which is a distributed cluster. Application 1 can send the data here. Application 2 can also send the data. Application 3 can send the data. Any application can send the data there. Some application can consume the data. Application 4 can consume the data. Application 5 can consume the data. Application 6 can consume the data. So this is how you need not send from application 1 to every other application. You send it to a central repository. This is where Kafka. This is much cleaner design and architecture. This is more cleaner design than the architecture here. Instead of transferring data from many application to many other application, you send it to one application, that is our Kafka. The Kafka comes into picture to solve such kind of a problem. So we are able to send a lot of data from lot other applications because it is a distributed message queue. Because it is a distributed message queue. So that's how we can say about the internals are just a overview of a Kafka cluster. Overview of a Kafka cluster. So here, what kind of applications can send the data? What kinds of application can send the data here? Here we can get the click stream data. Any clicks that are happening on a website, every click will be sent to the Kafka. We can get the ad impression data. Ad impression means whenever you log into not log in, whenever you open a Times of India web page, or whenever any web page which has a huge traffic, always you will see on the right hand side ads. So ads are coming as an ad impressions. Some company will be displaying those ads. So those things we call as a ad impression. Whenever an ad is displayed, the server gets a log. So ad impressions logs can be sent. Ad clicks can be also sent. You display the ad, some user clicks on that ad. So that is also a log. So it will come to know who has clicked the log, clicked the advertisement. Similarly, we can get the logs from the payment gateway. Every payment you book a ticket on Redbus, or you book a ticket on Clear Trip, or you buy something on Amazon, Flipkart, anything. At the last, you will do a payment. So there will be lot of payments going on. So people want to understand the payment, whether the payment has failed, whether the payment was success, what was the reason for the payment failure. So they can send all the data to the Kafka here. Similarly, we can get the data from some devices. We can get the data from devices. Many applications can consume the data, and it will be coming to the Kafka. So what all applications can consume the data here? We can have a Spark streaming application can consume the data. We can have Flink streaming application consuming the data. We can have Storm consuming the data. We can have Samza consuming the data. So these are all the processing framework. These are all the processing framework which consume the data from the Kafka. I mean to say, it is like a message queue, right? This Kafka is our message queue. Somebody is continuously sending the data to this message queue, distributed message queue. Somebody is continuously consuming this data from the message queue. So what type of application usually consume from the message queue? So these are all processing application, data processing application. Usually we have the data processing application that consume the data from Kafka continuously, and they will process it, and they will give the result. They will give the result. So that's what I can say about the Kafka here. That's what I can say about Kafka. Now what we'll say is how does the data is differentiated among others? How is the how the let's say this is IoT devices. How IoT devices data is differentiated from clickstream data. How clickstream data is differentiated from the ad impression data. How ad clicks data is differentiated from the payment data. The general idea is how a data from one application is differentiated from the data of another application. How does the Spark streaming can consume only clickstream data? How can a Flink streaming consume the data from ad impression? So how can I do that? So this is done using something called as a topic. So we give a name for each data here, a topic. So if you see ad impression and ad clicks, they are kind of a same application. They are kind of belongs to the same application. The idea here is it need not be that per application there will be one topic. We can have per application multiple topics also. This is a good example of that. So we can say a topic name as, for the click stream, I can say clicks. I can say topic is equal to ad impression. I can say topic equal to ad clicks. I can say topic equal to payment. Something like this. So I create a topic here. I create a topic. Who creates the topic here? Who creates the topic? It is the admin who takes care of creation of the topic. Let's say I have a 3-node cluster here. As I said, Kafka is a distributed message queue, and it is a persistent message queue. When I say it is a persistent, I forgot to say that the data is stored in the disk. The data is stored in the disk, meaning even if even when of the node goes down, one of the system goes down, the data is not lost. The data is not lost here. So that's the idea of the persistent storage here. Persistent storage. So let's say we have a 3-node cluster, a 3-node Kafka cluster here. The main working powerhouse or the working horses of the Kafka clusters are called as brokers. Broker 1, broker 2, and broker 3. So brokers are the actual working horses of Kafka. So what is their responsibility? The responsibility is to get the data, receive the data from the applications and save it on the disk. And it's one more responsibility is the application who wants to consume the data, they will connect to the broker and the broker will send them the required data. So it acts as a, you can say the name where it comes from. It acts as a broker between the application that sends the data and the application that consumes the data. So that's the broker here. That's the broker here. So let me take something called as a clickstream data. Clickstream or coming from the web servers. It is coming from the web servers. Let's assume that. I have web server 1, I have web server 2, I have web server 3 here. So there comes one more. This is our client application who wants to send the data to Kafka, the continuous data. As soon as you click on if you see, as soon as you click on Amazon, if you click on a website on Facebook, any clicks that you do on any e-commerce website or a Facebook website or many other websites, everything is captured as an Apache log, and those logs are sent it to Kafka for further processing as a message queue, and later it will be further processed. So as soon as you click, a record is sent to by this web server. From this web server, the data is sent to this broker. So how it is sent? There comes one more entity of the Kafka. It is called as a producer. The producer always sits at the client side. Producer always sits at the client side. Let's say I have producer 1 here, I have producer 2 here. For every web server, let's say there is a producer 1, 2, and 3. So the idea here is producer always sits on the client side. The job of the producer is consume this data, get the data from the web server, send it to the broker. It can send it to this broker also, it can send it to this broker also. Similarly, this producer can send the data to this broker also. It can send the record to this broker also, and it will send the data to this record also. Sorry, this broker as well. Broker is just a JVM process which is running on some IP address and the port. It is just a JVM process which is running on some IP address and the port, which will be receiving the data from these producers. As soon as it receives the data, it will save into the file. It will save into the file. It will save into the file. That's how the broker works. It gets the data from the producers and it will save the data from the broker. Here I may have a ad server. Ad server is one more application. Ad server is one more.
Pramod, could you please repeat that? Pramod?
Yeah. Which part to be repeated?
So you said that data will come from the, yeah, I'm asking that question. The data is producing from web server producer 1 and send to a broker. After that,
Okay, here the producer is sitting on the client side. It is an interface between the client application and the broker, or the Kafka cluster, we can say. So producer will get the data from the
correct.
web server and it will send it to the broker. Now the
Okay.
broker, what it does, it will save the data to the disk.
Which disk? Broker own disk?
Yes, yes. This is one system. This is system 1,
Okay.
this is system 2, this is system 3.
Uh-huh.
It will be returned to the disk on that system.
Okay.
Similarly, the data from here goes to,
Why,
pardon, your voice is breaking.
uh, why it written to the disk?
Why it returns writes to the disk? Because even if the system goes down, the data is still available. Data is not lost. I mean, I did not get the your intention behind the
But
question.
there is some consumer who will consume this.
Right, right. It will be
No,
consumed.
no. The intention is that there will be.
Your half of the, I'm not sure. Most of your words I'm not able to hear. The consumer part I will come to. If at all your question is all about
Yeah, can you
consumer,
hear me, Pramod?
yes, I can. Lost your voice again.
Yeah,
Uh,
his question is like why are we saving the message into discuss?
right. If your intention is why it is not sending it to the consumer, I will come to that point. Why it is saving to the disk and not giving to the consumer? Why the data flow is not directly happening to the consumer? If that is your intention, I will come to that point. I'm just assuming because I did not hear any
Uh,
of your words.
no, Pramod. My intention is it is in memory, right? I mean, actually, it should write in the RAM, right, instead of hard disk.
No, if you take any application, just forget Kafka. If you take any application, the very first thing it happens, it's in the memory. The data will be in memory, only then it will be sent to disk. So memory, it will be there, but finally it will be flushed to the disk.
So why I'm asking this question? So next, the consumer, when he is consuming, we need to read from the disk, right? Which is a time-consuming process.
Right, right. So what happens here is that it is read from the kernel space. It is read from the kernel space itself.
Okay.
So that we are not aware of actually. That we are not.
Pramod, one more thing. For producer, we are not sending a huge amount of the data, right? Because it is like it will be going small payloads, right? Then
Records.
why the, yeah, payload records? The payload record hardly it will be some an MB set per
Could be.
each payload.
Correct, correct.
So what I mean, I just want to interested by the it should put into the disk. So anyway, we will be having a memory. Why can't it be put in the memory? Once the consumer is interested, he can pick from that memory, right? From the topic.
If the system goes down,
Replica will be there, right?
a replica will be there, uh, but again, consumption will be very high. Memory consumption will be very high. So it may be running, for example, a company has receives 1 billion messages per day. if everything is in the memory, and they may store it for 1 week.
Correct. That's a default configuration, right? It will store the data into the memory for 1 week. After that, will get an exception like overflow kind of
Correct.
exception, right?
Memory is too much required here. Lot of memory will be required. It's not that.
That's what Pramod. I mean, why of the sorry to interrupt you. My intention is to understand. Anyway, the consumers will be running, or something happened to the consumer if he is not running. But in the within 1 week, the data will has to go to RAM memory. In the queue, it will be there. That's a default configuration where it can 1 week, that 1 week data it can store.
No, I'm just
After one
giving an
week,
intention of 1 week. That's the default. There could be 1 month also.
that we need to we can change. Um, I'm really interested on it will be more discrete. That is a where we got the spark and all, right. If we are writing into disk and reading from the disk, it's a little time consuming process.
No, no, that's what I'm saying, right? It's the kernel space from where it will be reading. Kernel space is still the memory. The disk is only for the
That's RAM you're telling, right?
right.
Okay, so if that is the case, why we should go with 1 week, 1 month? Anywhere it is writing into hard disk, we can save any amount of the data, right?
No, no, this question I didn't get.
So if it is writing into disk, why should we have that kind of configuration, saying like 1 week only I can keep, otherwise I spill out like that?
1 week.
No, Pramod, what I'm trying to say, if it is writing into disk, okay, the
Okay.
disk is a persistent storage, as you
Correct.
said.
Correct.
So we have some configuration like where we can the Kafka can store the data 1 week by default,
Right.
right? After 1 week, what it will do, it will start spilling out, where we will get a over messaging or some kind of exception, overflow kind of exception.
Okay.
If it is writing into the disk, why the need of this configuration? We don't need this configuration at all, right? We can store any amount of the data into disk.
Any
I think
amount.
there is something we are missing, I feel. Could you please make me understand that part?
No. Why do we want to save it for 1 week?
Correct.
So it is all the business requirement, right? We want to save it for 1 week. If you see, some data will be, they want the customer to available, the data should be available for 1 month. After that, they don't require the data.
Anyway, it is writing. If it is writing into disk, it is persistent, right?
No, the disk again, if you want it for 1 month, more disk space is required. More memory the client has to spill there. Sorry, more money the client has to spill.
Okay.
So that's the idea. So you can infinitely keep the data. You can keep the data for 1 year. You can keep the data for 10 years. For 1 year, 1 million cost may happen. For 10 years, 10 million cost will happen. So the client has to
Yeah.
think here now
Yeah.
whether he should
Correct. If that's the case,
one.
actually, the purpose of the Kafka is to get the streaming data, right? So I'm okay. I think somewhere I'm missing. Okay. You can continue, Pramod. I don't want to stop. Others will get disturbed. Sorry. Go ahead.
I mean, here today one streaming application is reading. After 5 years, one more streaming application wants to read it, or after 1 month. After 1 month, some other application wants to consume this data. So that also
Same
has,
data.
correct, the same data.
So at that time it will read from the broker.
Yes, it will read from the broker.
Okay.
So again, it's the continuous flow of data. It will be continuous, record by record, it will be reading. So you're thinking that from what I assume from your questions is that Whenever the data is produced, at the same time the consumer should consume it. No, that's not the idea here.
Not like at the same time. It's not like at the same time. There will be some delay.
No, not delay, I'm saying. Not delay, I'm saying. After 1 month, some other consumer can consume it. After 2 months, one more consumer can consume this continuous flow of data and do some other kind of a stream processing. I hope you that was the question. I think this question answer.
Go ahead, Pramod. I don't want to stop here.
Okay.
I mean, lagging somewhere.
Okay. Okay. There is some question on here. What if? Okay, 1 second. I guess this question is in that case consumer will be using it and what's the need to store it in the disk. It was designed to maintain latency. Let be known in what if we want the other app to read the next data and not the data that is stored in the router.
Pramod, it's Harpreet here.
Yeah, Harpreet.
Actually, if I have one Spark application, like Spark Streaming application, which is consuming data from Kafka, which is coming right now, it's consuming that data. And after that application, one more application, I'm starting one more application, seems streaming application only. So what is happening is that application is consuming the data which is already there in the broker. I don't want it to consume that data. I want it to consume whatever is coming now.
Whatever is coming now.
Yeah, whatever is coming currently. But what it do is it go and whatever data is stored in the broker, like in the disk, it consumes that data. So how do we handle that? It should consume the current data, like that offset should be updated and it should consume whatever the data which first application has already consumed. I don't want it to consume the same data. I want it to consume the new coming data.
Yeah, I got it, but I don't think so that I'm not sure whether this answer is correct or not, but I don't think so the Kafka is designed for that purpose. Kafka is just acting as a buffering agent in between the actual application and the processing application. Because there is, how does it know the current data?
Pramod, we can create checkpoint, we can store it in Zookeeper, and then from the checkpoint we can consume. Right now we are doing like this to avoid the data reading from the beginning.
The checkpoint.
Yeah.
Checkpoint, or you are saying the offset? Are you saying the offset?
Yeah, offset. Yeah, correct.
No, offset.
So you are storing the offset.
No, how does the second application know the latest offset?
We can pass this path to the second application, the checkpoint path. I have done this and
Right.
I have done the testing also.
Okay.
Yeah. Okay.
That's correct. That's correct. Okay. We have the offset here. The consumer C1 gets the offset. So you will send that offset to this application, or sorry, my mistake. 1 second.
The question is like you want to consume, you want to two separate program for the consumer, right?
Consumer 1, consumer 2, it takes the offset and it gives the offset to consumer 2, you are saying. The latest offset. But does it mean it is the latest data for consumer 2?
Pramod, it seems that if you want to communicate between one topic to another topic, once the data come to one topic, from that we want to redirect to another topic where other consumer can consume. I think so. That's maybe his idea.
No, if we want to consume the data from the same topic, data is
Yeah, I
coming in
understand.
one topic, but two applications want to use it. And the data which one application has already used We do not want
that
the
is
other
that can be
application.
handled. That can be handled, Harpreet. That there is something called partitioning. Okay, so if the partition, right, one there will be two consumers. Let's assume that one consumer is sending the data to application one, other consumer is sending the data to other application. So when the data comes to the topic, there is something called partitioning. So it will partition the data. Whatever the data goes to consumer one, that data will not come to the consumer two.
No, I think that's not.
Okay.
Partitioning.
Actually, my second application is starting little late. One first application is already consuming. After that, if second application is coming up, will partition will be like this concept will still work? The
We'll find
partitioning.
out here since one application is reading from one consumer only. So other application will read from other. See, one thing we need to understand: once the data comes to the topic, there is something called partitioning.
Yeah,
So based on the number of
so I think I will partitioning I will cover. Partitioning
okay.
I think I will cover. So as of now, let me check that. The idea here is we have consumer one, consumer two. Senthil, just correct me if I am wrong. Consumer one is reading the data from the broker, right? Now consumer one may not read the latest data because the producer may be sending the rate at much faster rate. Consumer may be consuming the data at the slower rate. Here the producer has sent 100 messages. The consumer may be still consuming the 50th message. It is possible, right? May
Yes,
not.
it's possible, Pramod, and there is something called synchronize. I mean, I forgot the terminology. So since consumer one sends acknowledgement to the I mean, can say it, producer, it will not send the other part. That can we can handle it. Once the consumer one takes the data, he will process and he can send the acknowledgement to the producer.
No, produce consumer doesn't contact the producer. It contacts
No,
broker.
it means that no, the consumer can producer can check whether it can wait for the acknowledgement from the consumer.
Not from the consumer, but from the broker.
Ideally, in between he is agent, right? Yes.
Yes. Yeah. What I'm trying to say is, producer is has sent 50, 100 messages. Consumer is consuming the 50th message. So if it says the same to the consumer too, if it says to the application one, I will say, and application two. Now application two will be start consuming the 50th message. It may not start consuming from the 100th message. That is my idea. Is
From the broker.
Senthil, this is how you solve the problem?
Uh, no, Pramod. Your question is like one consumer will consume 50 messages, another consumer will consume 50 messages. Is that?
No. The question from her is,
Uh, one kind suggestion is like, why don't we complete this?
yeah,
We'll
yeah,
have
sure,
debate at long.
sure. We will complete that. That's a good suggestion.
Because
Yeah. I'm
because
sorry.
people are waiting.
Yes, sure.
I'm extremely sorry that I got diverted. Sorry. I will move ahead with this.
Yeah.
I'll move ahead. So what I was trying to say here is, the data is stored in the disk. The producer sends the data to the broker. Broker saves the data to the disk here. The producer will also send the probably the first message it will send to broker one, second message it will send to broker two, third message it will send to broker three. Probably based on the round robin, which is the default, it can take. Fourth message again it will send to broker one, fifth message it will send to broker two, sixth message it will send to broker three. So this is how This is called a round robin fashion. Producer one will be sending the data to. This is how the scalability happens. This is how the scalability happens. In a similar fashion, there could be a web server also, ad server also. There will be ad server 1, ad server 2, ad server 3. So this ad server will also be sending the data to broker 1. Ad server 1 will also be sending the data here. Ad server will also send the data here. Ad server 2 will also send it here. Ad server will also, ad server 3 will also send the data here. Ad server will also send the data. So a one broker can handle messages from different application. We need not have one broker for one application. That was the idea I wanted to say here. One broker can handle, I think it can handle thousands of partitions. We'll see what is this partition. We'll see what is this partition. So now how does the broker differentiate the data from clickstream? How does the broker differentiate the data from ad server? So the way it differentiates is using the topic. So the topic will be created. So the system admin or the admin person will create a topic saying that create topic. You can say topic is equal to add server, add impression. Add impression, I will say. So he or she may say partition equal to 4, it can say, or 6, anything. Replication, it can say about, let's say replication is equal to 2. Let's say we have 3 servers. Let's say we have 3 servers here, or 3 brokers, will say. Let's say we have 3 brokers, broker 1, broker 2, and broker 3. So whenever this topic is created, a folder is created here. Add impression -0, probably add impression -5, add impression -3, add impression -2, add impression -1, add impression -4. So what it creates is, it creates 6 folders, because we have specified 6 partition. And since there is 2 replication, these will be replicated in 2 other system. These will be replicated in 2 other system. Just like it will have add impression -0 also here. Add impression -5 also here. Similarly, 0 and 5 is replicated 2 times. I mean, replication 2 means we will have a 2 copy. One the original copy, one the replicated copy. Add impression 3 may come here. Add impression will have 3 here. Probably add impression 1 may come here. This may be replicated in this broker. Add impression 4 may come here. This is replicated here. Add impression 5 may come here. So this is how a folder is created inside the disk or some file system. So normally Linux file system, it is created, a folder is created in the Linux file system based on this. So now we have clickstream. Now who will decide which is the main partition and which is the replication partition? Which is the main copy and which is the replicated copy? So who decides this? How do we know that which is the replicated copy and which is the original copy? So this is which is controlled by the controller. There is something called as a controller here. There is something called as a controller. Just before that, just before going to that, let me show you how it looks like. I have it in my So first we need to start the Zookeeper server. Kafka depends on Zookeeper. I will say why it depends on, but let's see how it looks like. So this is how we start the Zookeeper. This is the shell script to start the Zookeeper. This is the Zookeeper properties. This is the Zookeeper properties. This is how we start a Zookeeper. The Zookeeper is up and running. It runs on 2181 port. Similarly, I can start the Kafka server. When I say Kafka server, I actually mean internally it means a broker is starting. We are starting a broker. So I will try to run 2 brokers. For each broker, I will have 1 property file. I will start running 2 brokers. This is the first broker property file. This will start the first broker. This will start the first broker. The broker ID that I have specified is 111. The broker ID I have specified is 111. We can check the configuration file here, server 0.properties. So we'll see here, this is the broker ID. It should be a unique ID. Broker is running on 9092 port by default. So network threads, there is an importance because of these network threads and IO threads, a single broker can handle thousands of partitions. It is all because of threadings. This is all because of these 2 threads. And this is the path where the data will be stored. This is the path for broker 1 where the data will be stored. So these 3 are as of now important. These 3 are as of now important. Similarly, I will start second broker. Similarly, I will start the second broker. Kafka server start config server1.properties. This time I will give server1.properties. Earlier I gave server0.properties. This time I will give server1.properties. Let's check what is there inside the server1.properties. So I can see here the broker ID is different. Broker ID is 222 now. It is running on different port. Because I'm running it on the same system, we cannot run 2 processes on the same port. That's the reason I have changed the port here. I have given 9093. And each broker should have its own disk space. Each broker should have its own disk space. Hence I'm giving a different path here. So whenever I start a broker, this directory gets created. This directory gets created. Let me go and check in the temp folder. If I go and check in the temp folder, you can clearly see that the data is existing here. The data is existing here. So now what I can do is, as I said, we need to create a topic. We need to create a topic here. So the way I create a topic is Kafka topics. This is how I create a topic. This is the command to create a topic. Kafka topic.sh. Zookeeper has to be given here because the topic information will be stored in the Zookeeper. The topic information will be stored in the Zookeeper. The options are create a topic, specify the topic name here, specify the topic name, specify the number of partitions that you want to specify. I can say I want 4 partitions, and I will say replication factor. Let's keep it as 1 as of now. I require 4 partitions for this topic. So let's see what happens when we specify 4 topics. So I can go to the Kafka. This is the disk space where the data will be there. So you can clearly say that there is a folder got created with the Kafka. There is a folder got created with the topic name Apache-1 Apache-. Here is the question. The question is, partitions are just copy of a topic, or is it part of a topic? It is part of a topic. Means a topic means a data. Topic means it is a, if you want the web server to send some data to the Apache topic, it will be sending to the Apache topic, but the data will be distributed among different partitions. It is a part. Apache-1 will contain some part of the Apache topic. -3 will contain some part of the data. So broker one handles 2 partitions. Broker 1 handles 2 partitions. I can say Kafka broker, this disk space belongs to broker 2. So broker 2 handles 2 partitions, Apache-0 and Apache-1. So this is how the data is distributed. That's what I was trying to say here. This is what I was trying to say here. So it will be data will be stored on the disk. So this is how it differentiates. Now I can create one more topic. Say I will say create topic. I will say add impression. One more topic. I will say add impression. Again add impression. I will say 4 partitions and replication factor as 1. So we can see that one more folder gets created. So if you see, for add impression, this is the topic name, -1 is the partition 1, -3 is the partition 3, or we can say broker 2 handles partition 1 and partition 3, and broker 1, if you see, broker 1 handles partition 0 and partition 2 of add impression data, So the data gets divided in this fashion. So this is how a data is differentiated. Whenever a add impression server sends the data, it has to say that I am sending the data to this topic. I am sending the data to add impression topic. Whenever the web server or a clickstream server wants to send the data, it has to say that it is sending the data to Apache topic. So this is how the data is sent. And I said, who sends the data? The broker sends the data. Who sends the data? The broker sends the data. Now how does a now everywhere we specified Zookeeper. Why Zookeeper is required here? What I will do is, let's go to the Zookeeper shell here. Let's go to the Zookeeper shell. So this is my Zookeeper shell. I can see what all is there inside the Zookeeper. We have a controller. Controller is an important entity. We have a brokers. Brokers is also important entity. We can say brokers. We can say broker IDs here. So as I said, we had started two brokers, hence those two brokers are available here. Hence those two brokers are available. We can also see the topics here. Brokers, topics. So if you see, I had created two topics, those topic information is available here. The topic information is available here. So all the configuration related to the topics or the brokers is available in the Zookeeper. We still did not say what is the use of the Zookeeper. What is the need to store all these things in the Zookeeper? What good it will bring to the Kafka? What problem it will try to solve with the Kafka here? So let's what we'll do is, the very first thing that I will do is I will stop. Let's see, these are the things that are available as of now. Let me stop the Kafka server. I'll just stop the Kafka server. Let the Zookeeper server be up and run. The Kafka server has stopped, shutdown complete. Kafka server has stopped, shutdown complete. Let's once again log into the Zookeeper shell. Let's again do here something. So something got lost here. So what is that is lost? Okay, my mouse is not working. So if you see the earlier one, when we said it had a controller. If you see, it had a controller. The controller is gone here. So what is this controller? It has an important role to play in the Kafka. So what is this controller? So controller is nothing but we'll see what is a controller. So what I will do is I will start the first broker once again. I will start the first broker once again. Let me start this first broker once again. So as soon as I start the first broker, okay, 1 second, my mouse is not working fine. Just a second. Right. Now I started the first broker once again. Let's check whether that controller has come up or not. I will do ls. So we see that controller has come up again. So what is a controller here? Controller is nothing but it's again a broker. The very first broker that we start, that becomes the controller. And what is the responsibility of the controller? The responsibility of the controller is to assign topics and partitions to different brokers. Now when I created, so when I created Apache topic, here, so broker 1 got Apache 1 partition and Apache 3 partition. Why did it get? I mean, why did not it get Apache 2 and Apache 4, Apache 0 partition? So this decision was taken by the controller. So controller is the one who gives brokers the partitions. So what it does is let's say for example, somebody should be acting like a controller or a master here. The very first broker we start will become the controller. The very first broker we start will become the controller. And whenever we say create a topic Apache. So, and let's say there is broker 1, broker 2, broker 3, broker 4. And I create Apache topic and I will say partition, just for understanding purpose I am putting this, I will say partition as 3. Partition as 3. Now I started broker 1 first. Broker 1 is started first. Hence it becomes the controller. Hence it becomes the controller. So what it does is, now whenever I create a topic, so it's the controller's responsibility. The controller's responsibility to allocate partitions to different brokers. And I will say replication as, and I will say replication as 2. I will say replication as 2. So what this controller will do is, it will allocate Apache 0 to broker 2, possibly. Randomly it chose Apache 1 to broker 4, Apache 2 to broker 3. So this controller gives such a, controller decides this which broker will get the which partition. And it will also decide that which partition will get, which broker will get the replication. Probably Apache 0 may come here, Apache 2 may come here, Apache -1 replication may be coming here. So if you see, there are, I am saying replication 2, there are 2 copies of partition 1. There are 2 copies of partition 0. There are 2 copies of partition 2. And who decides of allocating these things to which broker? So it is done by the controller. It is done by the controller. That is the responsibility of the controller. Meaning now, the controller knows about all the brokers. It knows which topic has been assigned to which broker. It knows which partition is assigned to which broker, which replication is assigned to which broker. So the broker 1 knows, the controller knows everything. And the same information it will convey to every broker. The same information it will convey to every broker. So broker knows about every other, a broker or the controller broker knows about every other broker because it itself allocated those partitions. Once everything is done, it conveys that information to every other broker. And the controller broker will be watching every other broker, and every other broker will be watching the controller broker. So any change happens to the broker, any one of the broker, a notification will be sent to the controller broker. All these happens through the Zookeeper. Now what is the use of conveying all this information to every other broker? By doing such a thing, every broker knows about every other broker. Every broker knows about every other broker, meaning broker 2 knows what all partitions are available in broker 3, what all replications are available in broker 3. Similarly, broker 3 also knows everything about other brokers. So here is the question. The question is, where does this controller broker run? It is one of the broker. We have 4 brokers, broker 1, broker 2, broker 3, broker 4. Whichever is the first broker we started. I started broker 1 now. So if you see, I have started broker 1. As soon as I started broker 1, it created this controller folder or a node inside the Zookeeper, and hence it became the controller broker. It is one of the broker. Now when we start, Now when we start broker 2, now when I start broker 2, if you see I am starting the broker 2 now. When I start the broker 2, broker 2 will also try to become the controller. Broker 2 will also try to become the controller by trying to create this folder. But it will see that this folder is already created, hence it will fail. Hence it will fail. If I start some 5 brokers, every broker will try to create a controller folder. Whoever succeeds in creating this controller folder, they will become the controller broker. It is one among the brokers. It could be broker 1, or it could be broker 2, or it could be broker 3, anything. Any broker could be a controller. Now I'm assuming that broker 1 is the controller. Broker 1 is the controller because on the Zookeeper it created a folder called controller. Now broker 2, broker 3 and broker 4 will be subscribing to this controller node, this controller folder. This controller folder, any change happens to this controller folder, a notification will be sent to broker 2, broker 3 and broker 4. What is the need of that? The need of that is if broker 1 is down, which is our controller node, which is our controller broker, then if after this if I create one more topic, who will allocate those topics to different brokers? Somebody should allocate those topics to different brokers. If the broker 1 is down, who will do that? What happens is if the broker 1 is down, this node gets deleted or this folder gets deleted from the Zookeeper. Deletion is kind of a change that happened. So as soon as the change happens, Zookeeper send a notifications for broker 2, broker 3 and broker 4. Now broker 2, broker 3 and broker 4 will compete to create this controller folder. They will compete. Whoever wins in creating that folder, that broker will become the controller. So always there will be one controller. Always there will be one controller. Now because of the controller, every broker knows about every other broker. Every broker knows about every other broker. Some broker will be chosen as chosen to handle the master replica. Some brokers are chosen to handle the master copy. Some are chosen to handle the replication copy. Right, yes. Does the controller broker changes every time the server gets started? Yes, it will. Yes, it will. The meaning here is, I mean, let's I have started server 1 and server 2. Let me stop this server again. Let me stop the Kafka server again. Kafka server stop. Server 2 also has been, broker 2 is also. Now what I will do is I will not start the broker 1, I will start the broker 2. I will start this broker 2. Now broker 2 will become the controller. Now broker 2 will become the controller. I hope that you got the answer. I was able to convey the answer. Every time, I mean, wherever the whole cluster is down, whenever the whole cluster is down, and whoever comes up first, or whoever is able to create that folder first, that broker will become the controller. That broker will become the controller. And the controller chooses, now the controller has chosen, let's assume controller chose B2, broker 2 has has original master copy, and B3, not B3, yes, B3 has a replication copy of Apache topic, Apache 0 partition. Broker 2 has the master copy. This partition is the master copy. Broker 3 has the replication copy. Similarly, broker 3 has master copy of Apache 2 partition. Broker 4 has replication copy. Broker 4 has replication copy of Apache 2. Similarly, broker 3 has master copy of Apache 0, Apache 1 of Apache 1, and broker 2 has the replication copy of Apache 1. So what it means here is with respect to these things, broker 1, or I will say broker 2, is leader for Apache 0 partition. Broker 2. Broker 3 is, sorry, not broker, yes, broker 3 is follower of Apache 0 partition. Similarly, broker 3 is leader for Apache partition 2. Broker 4 is follower for Apache, what is this? Apache 2 again. In a similar fashion, broker 3, did I do something wrong here? Oh, broker 4, sorry, my mistake. Broker 4 is has the master copy for this. Broker 2 has the master copy, replication copy. Because that's the reason we'll say broker 4 is the leader for Apache 1 partition. Broker 2 is the follower. So what is the meaning here? Means every broker is a leader, every broker is a follower. Every broker is a leader for particular partition, Meaning broker 2 is responsible for these two. Broker 2 is responsible for Apache, sorry, my mistake. Because we are saying replication has 2, right? Broker 2 is responsible for this. Broker 3 is responsible for this. Broker 4 is responsible for this. Meaning we have broker 2, broker 3, broker 4. Here I have Apache, what is that? Apache -0. I have Apache -1, sorry, 2. I have Apache -1. So if a producer wants to write the data to Apache topic, so producer should contact broker 2 for writing to Apache 0 partition. The producer must contact broker 3 to write to Apache 2 partition. Producer 1 should contact broker 4 to write to Apache 1 partition. And where are the replication available? These are all replication. I will just say R here, just for the understanding purpose. But usually nothing will be there. Internally everything will be maintained. I will say Apache 2 also is a replication. And I will say Apache 1, which is also a replication. The, the producer will not write data for this. Producer will not write. Producer will only connect to the leader. Broker 2 is the leader for Apache 0. Broker 3 is the leader for Apache 2. Broker 4 is the leader for Apache 1. So the producer will always connect to the leader to write the data to the partition. Even though broker 2 has a replication of Apache 1 partition, producer 1 will not connect to broker 2 to write to Apache 1 partition. Always the communication happens through the leader only. Let's say I have a consumer here. If the consumer wants to consume the data from 0th partition of Apache topic, it should not connect to broker 3. It should not connect to broker 3. Who is the leader for Apache 0? Broker 2 is the leader, hence it will connect to the broker 2. So the meaning here is the read and write always happens through the leader copy or the master copy. Whichever broker is handling the master copy, the communication happens through that broker. Communication happens through. Now how this replication is maintained? How this replication is maintained? I mean this replication. Apache -0. The way the replication is maintained is broker 3 will contact broker 2. Broker 3 will contact broker 2 and it will get the message from the broker 2 and it will write it into the replication. Similarly, broker 4 will contact broker 3 and it will get the message of the master copy and it will write it to replication and it will write it to replication. Sorry. So I hope till here things were clear. I hope till here things were clear. Any questions still here?
Yeah, I have a question.
Yeah.
Yeah, how does round robin method comes in picture over here?
How does round robin method? Even I can just say that round robin means it will be decided. I think it's a by default. I'm not sure. Round robin means the partition 1 will send the first record 1 to broker 1, record 2 to broker 2, record 3 to broker 4. Record 4.
Okay, that will be
Yeah, go ahead.
that will be taken care by Zookeeper, as per my understanding.
Zookeeper, no, it will not be taken care by the Zookeeper. It will be on the producer side code. On the producer side code because the reason I'm saying that whenever you send the data here, whenever we send the data, we can write our own partitioner. We can write our own partitioner.
Okay.
So we can decide what partitioner we want. We can write a hash partitioner, or we can write a partitioner such that all the error record goes to broker 2, all the warning record goes to broker 3, and all the info record goes to broker 4. I think it should be in the broker side, sorry, producer side, but I'm not anything. Senthil can add something here.
I don't think so, Pramod.
Who is this? Ankush. Yeah, Ankush, go ahead. Yeah, here is the thing. If you won't specify any partition key, then the data will be stored on a single partition. Yes, that's true, but we can specify the partition key. I mean, partition key is different, partitioner is different. We can ignore the partitioner and only provide the partition key. Or we can both provide partition and the partition key. So we'll see that, we will see that. But as per my understanding, I think the round robin comes on the producer side. It comes on the producer side. Now there is one more question. Then producer or consumer need to know who the leader is of each partition. What if broker 2, that is the leader of Apache 0, is down? How the client or producer will know who is the leader or the right? That's the let me answer that question. The question is, now how does producer know that it has to send the data to broker 2? I mean, there may be broker 1, there may be broker 5, there may be broker 6, there may be broker 7 also. And we are saying that broker 1 is the controller, and the controller decided that Apache topic will be stored across broker 2, broker 3, and but there are other brokers also. Broker 6 is there, broker 7 is there, broker 6, 7 is there, broker 1 is also there. Now how does producer, how does producer 1 or producer knows that it has to send the data to broker 2 or broker 3 or broker 4? How does it know that it should not send the data to broker 5? How does it know that it should not send the data to broker 6? The way it happens here is, we provide something as a bootstrap server. Bootstrap server are some 2 servers. Minimum there will be, we have to specify 2 servers. Here I have specified only 1, but it is recommended to specify 2 servers. So if we go by this example, in the producer code we have to specify bootstrap server. So bootstrap server, I will say B5 and B6. This will be configured by the admin person. The producer, I said broker 5 and broker 6 are the bootstrap server I will configure. So what it does is, the producer, what it does is, first it will contact one of the server, because the producer only knows these 2 server now. It does not know anything about the cluster. The producer does not know anything about the cluster. It only knows about whatever is the bootstrap server configured, whatever is the bootstrap. So it will try to contact one of the bootstrap server. As it contacts one of the bootstrap server, let's say it connected B5. The producer contacted B5. And what I told about the controller, I said that control is the one which allocates leaders and followers for each topic. And I also said that the controller broker will convey that information to every other broker, meaning every broker will have the information about every other broker. Now broker 5 also knows that Apache topic is stored in broker 2, broker 3 and broker 4, and it also knows that partition 0, broker 2 is the leader for partition 0, broker 3 is the leader for partition 2, broker 4 is the leader for partition 1. All this information is available in the broker 1, broker 5. So that information is returned to the producer. All the metadata information is returned by the broker file to the producer. Now producer knows that broker 2, broker 3 and broker 4 are the three brokers which handles the Apache 0 topic as a leader, Apache 2 topic as a leader, Apache 1 topic as a leader respectively. So I hope that question was clear. So this is how a producer comes to know about what it does is, let me give some diagram here.
Pramod, could you show me the logic that you have explained in the code, that how this I mean broker 5 fails, that producer will redirect to the other brokers
Yes,
and
yes.
other stuff?
Yeah, I will try to explain that as well. So before that, so if you see, this is how the request happens. This client is nothing but it could be producer or it could be consumer. The producer or the consumer will send the metadata request to any one of the broker. Any one of the broker. Why I am saying any one of the broker is, initially it will be the bootstrap server. The very first time it will be the bootstrap server. The producer will contact the bootstrap server and it will send a request saying the metadata request. So the bootstrap server will respond with the metadata response, which contains the details of every other broker and the partition of every other broker. Once the producer gets that information, it will send the data to the broker. So this is how it happens. This is how it happens. Now let's say, where is it? Now let's say broker 3 is down. Now let's say broker 3 is down. Now obviously the producer cannot send the data to Apache 2 topic because broker 3 was the leader for Apache 2. Nor let's say consumer also is there. So consumer 1 was consuming the data from this. Now the consumer 1 also cannot consume the data from Apache 2. Nor the producer can write the data to Apache 2. So that should not happen. That should not happen. So did I draw the diagram somewhere else where the broker produces? Yeah, this is the way, right? So let's say broker 3 is down. Let's say broker 3 is down. Obviously what happens, producer cannot send the data to broker 3 for this partition. It can send for data for this partition, it can send the data for this partition also. It can send the data to other two partitions, but it cannot send the data for this. Now how does it handles? How does it handles? The very first thing that happens is one more broker will be allocated. One more broker will be allocated. Who will become the other broker? I mean, somebody else should become the leader for this partition. Somebody else should become the leader for this partition. Only then the producer will contact that leader. Who else can become the leader? Can B5 become the leader? If B5 becomes the leader, nothing data is there. It cannot serve a consumer. Nor B5 can become a leader. Nor B7 become the leader because none of them has the data available. So only broker 4 and broker 5 will become the leader, and broker 5 will become the leader. So I think here, just let me assume one thing here. I'm assuming here that again the controller will make one of these things as the leader. Either broker 2 or broker 4 will become the leader for Apache 2 partition. Apache 2 partition. Possibly I am just assuming one thing here, that broker 1 will be choosing, the controller will be choosing that. Let's assume that controller has chosen broker 4 as the leader, because partition is available, the replica is available here. Let's assume that broker 4 has become the leader. Now how does producer know that broker 4 is the leader for partition 2 also? How does it know that broker 2 is the leader for partition 2 also? Again what happens, one thing, as I said, since controller made broker 4 as the leader for partition 2, it conveys that message to every other broker. So every other broker knows that broker 4 is the leader for partition 1 as well as a leader for Apache 2 partition. Now broker 1, sorry, now the producer 1 will send the data to, will try to send the data to broker 3 here, but broker 3 is down. So obviously it will get some exception, exception error. It will get the connection exception error. Next what it will do? Next what it will do is, it will contact any one of the broker, because the very first time when it contacted the bootstrap server, it had all the broker's IP address. It got all the broker's IP address. Now producer knows all the broker's IP address, so it will contact randomly one of the broker. That's what this says, any broker. This is the reason why it says any broker. The very first time this will be the bootstrap server. The next time whenever it gets an error while contacting the leader broker, as soon as it gets an error, it will again send a metadata request to any one of the broker, which it has, because it has maintained the metadata cache. From that request, let's say it contacted broker 6. Let's say it contacted broker 6. So broker 6 will convey the information that broker 4 is the leader for Apache 2 also. Broker 4 is the leader for Apache 2 also. That metadata information will be available here. So using that, now the next request will go for broker 4. It will no more contact the broker 3. It will no more contact the broker 3. So I hope this error handling was clear. I hope the error handling was clear. So this is how the internal, it's all about, that's the importance of controller. That's the importance of controller. One of the broker acts as a controller. If one broker goes down, it handles that. And it conveys that information to every other broker, meaning now every broker knows the updated state of every other broker. So the producer or consumer can contact any broker and get information of every other broker. It can get information about every other broker.
Yeah, thanks, Pramod. May I know what does the term bootstrap server means? Is it a, combination of different brokers, or what? What does the bootstrap mean?
Yeah, bootstrap server, it's nothing. I mean to say, you may have a 20 node cluster. You may have a 20 node cluster, Kafka cluster of Kafka. When I say 20 node, each node one broker will be running. Each node one broker. So we are having broker 1 up till broker 20 nodes. We are having 20 brokers. So producer, we did not specify all the 20 brokers for the producer. We only have to specify one or two brokers. Usually recommended is 2 broker address we have to configure in the producer or consumer, so that the producer becomes aware of the Kafka cluster. The producer needs only one broker to contact. As soon as it contacts the first broker, it will get the information of every other broker. So it is to make aware the producer that what is the Kafka cluster, how many nodes are there in the cluster, which broker handles which topic, all those things. So that's the idea of the bootstrap.
Okay, so you said that at least the preferred standard is like at least the producer should be configured with 2 brokers. So that it means that out of those 2 brokers, one should be a leader or it can be
Nothing
a
like
follower broker as.
nothing like that. Any 2 broker. The idea here is
Okay.
whenever the producer is starting, as soon as it starts to send the data, at that particular of time, one of the broker may be down. If you are configuring only one broker, and the time we start the producer to send the data, at that moment, if the broker is down, it will be not able to connect to the Kafka cluster at all. It will be not able to connect to the Kafka cluster. So it is just for redundancy purpose. If one of the broker is down, it will connect to some other broker. That's all. And leaders and followers are only with respect to partition and replica, main copy and the replica copy. So every broker is a leader, every broker is a follower with respect to some partition and its replica. So I hope that.
Could you please show me a producer example doing the same thing?
Yes.
Code. I mean, no need to run it, but at least the high-level view of the code.
So this is have a producer example. So bootstrap server, I have specified only one IP address because I'm running on the single system. Usually it is 2. Recommended it. So something we call have acknowledgement all. So what it means, acknowledgement all means we can have acknowledgement 0, acts 1 and acts all. So there are three values available for that. Act is 0 or 1 or all, I suppose. 0 means this is a message, this configuration is to convey to the broker that I don't need a reply from you. I don't need an acknowledgement from you. When I say 0 here, it means the producer is saying to the broker that I don't need any acknowledgement whether the data is being received or not. We don't care about the reliability. When we say 1, when we say acts 1, so the producer is conveying to the broker saying that as soon as you receive the data, send me an acknowledgement. That's what the producer is saying. And when we say acknowledgement all, so the producer is again conveying to the leader saying that as soon as you save the data in your disk, and as soon as all the brokers saves in the replica, send me an acknowledgement. So what I'm trying to say here is, trying to say now, producer 1, just a second. Yeah, producer 1 sent record 2 to Apache 2, I mean broker 3. It sends the record to Apache 2. So broker 2 will write the data to Apache 2. Broker 4 will copy it from broker 3 and it will save it on its replica, and it will save it on replica. After saving the replica, it will send a acknowledgement. As soon as the broker 3 receives acknowledgement from here, it will send a acknowledgement. So this is what we mean by ACK. All. This is what every replica has to be written. Every replica has to be written. Similarly, retries means whether the producer wants to retry or not. Similarly, this Avro serializer means you want to serialize your data using the Avro file for Avro record. As an Avro record, you will be sending the data to the producer, to the Kafka cluster from the producer. So this is our data. We are sending a record which contains 3 fields: time, site, and IP. Time, site, and IP. So the topic I am seeing as a page visits. Page visit. Page visit is a topic. So one more thing is, when we send an Avro data to the Kafka cluster or to the broker, we also need to send the schema along with that. So which unnecessarily creates more size for the data. Let's say it will double the data size. We have a timestamp to be sent. We have site, website address, and the IP address. Every record will contain these fields. Every record will contain these fields value in this fashion. If you see, I am creating these fields. I am creating a page visits object, and I will be sending that object to the producer, from the producer to the Kafka cluster. But when I send this record, how does the consumer will decode this? How does the consumer will decode this? The consumer needs to know the Avro schema. It needs to know the Avro schema. So earlier what was happening is, the schema was also sent along with the record. So that unnecessarily doubles the size of the record. Doubles the size of the record. So to solve such a problem, they came up with something called as a schema registry. Schema registry is one more server that will be running. With Kafka Confluent, this comes by default. This comes along with the Kafka Confluent. If you are using the Apache Foundation's Kafka, so you have to explicitly download this schema registry separately from the GitHub. But if you are using the Confluent version of Kafka, the schema registry will come along with that. So it will start writing the. So what happens, instead of sending the schema for every record, we will store the schema in one central schema registry. Now the consumer will, when the consumer wants to decode this Avro record, it will get the schema from the server schema. It will get the record schema from the schema registry, and it will decode the data. That's how it happens. Just what I will do is, I will try to send the data to this broker. Actually, let me stop this brokers, because this is my Apache Foundation broker, which does not support Kafka, which does not have schema registry. Hence, I cannot send the Avro records. I will start the Confluent one. I will stop this, and I will also stop the Zookeeper. So Zookeeper is started, and also you need to delete that folders. So you need to delete all these Kafka related folders, rm-rf, Kafka start, and also remove the Zookeeper details. Otherwise, it will take the previous Zookeeper information itself. So what I will do is, I have my Confluent Kafka installed somewhere else. I will go to that path. So you can go to downloads. You can go to downloads. You can go to training. I have Kafka here. In Kafka, I have Confluent 3.0 using. I will go to there. So I did not configure it in the bash RC, hence I have to go there and give the commands. Kafka. I will start the Zookeeper. Zookeeper server start. It is not the shell script, it is a binary. And the configuration file is in etc folder. etc Kafka, then zookeeper.properties. So this is how I start the Zookeeper. The steps are same, but the configurations are at different paths, that's all. Just exit here, exit here, exit here, exit here, exit here, Control Shift T. Again, I will start the Kafka server. Kafka server start, etc Kafka server 0.properties. Again, I will start two brokers here, two brokers. So broker 0 has become now the leader. I mean to say became the controller. Again, Kafka server start config etc Kafka, and then I will say server 1.properties. I will start this. So we'll also start the schema registry. It is again inside the bin folder. Schema registry start. You need to start this server also. Again, the configuration is in etc schema registry dot properties. Start the schema registry also. It will start the schema registry. You can see that this is the URL where the schema registry will be. This is where it will be running. So you need to specify this in this URL you have to specify in your configuration parameters for the producer. So let me run this producer here. Before that, let's create a topic saying page visits. Let's create a topic page visits. It's the same thing, but this will take the other one. So I have to give, and this is not sh topics minus Zookeeper. We have to specify create topic. I will say page visit. Page visit. I will say partition 2, replication 1. Replication 1. So we have created a page visit. So we can go and check where the page visit is there. The path I have kept it the same, slight change. This is the disk space for broker 0. This is the disk space for broker 1. We can go and check here. So page visit, broker 0 is responsible for, is the leader for partition visit -0. So if I go to partition visit -0, so you can see that this is the file where the data will be published, or the producer will send the data to the broker and broker will save the data to this file. To this file it will save the data. In a similar fashion, you can check for broker Kafka logs broker 1. Go to there, we can see page visit partition exists. I can go to page visit partition 1. Again it has a dot log. Again it has a dot log. So the data will
Pramod, before sorry to interrupt, Pramod. Before going further, I just want to understand the Kafka service what you have run right now, which is currently running. Is it Confluent Kafka or Apache Kafka?
It is Confluent Kafka.
So you also started a schema registry server, right? So schema registry server runs only for Confluent Kafka, not for, we can't use Confluent services schema registry for Apache Kafka service, right?
What I mean is the schema registry comes along with the Confluent. The Confluent has come up with a package. If you want
Right.
to use schema registry with the Apache Kafka, so you have to explicitly download that and use it with the Apache Kafka. But with Confluent, it comes built in. So we can directly go ahead and use it.
Okay. Now we are, whatever the example you are showing, we are completely using the Confluent platform only, right?
Yes. Yes.
Okay. Thank you so much.
Yeah, we can imagine just like this. Hadoop Apache we have, Hadoop from Cloudera we have, or Hortonworks
Yes.
we have. In a similar fashion, these are from Confluent is a company which gives the distribution of Kafka and which is behind Kafka as a community, which maintains Kafka.
Okay. Thank you.
So now we create these topics. Now I can, yes, Confluent has free version as well as the support version. Support version.
Commercial version.
So we created a page visit topic. So when let's run this program. Before running this program, let's check what are all the configuration parameters I'm having. So I'm trying to send some 100 records, and the URL I'm specifying schema registry URL is this. This is what we saw it when we started the schema registry. 8081 is the port. So our producer will send it. Before sending, internally it will take care of sending the metadata request, getting the actual broker IP address, then it will send the data to the data. All those things happens internally. The code we need not understand, but I have the code somewhere else in my consumer class. We can use that to understand more. So let's run this program. And one more thing I forgot to say here, as producer sends the data record 1 to broker 2, what does the broker will do is, broker will assign an offset to the record. Offset 0 for record 1, offset 1 for record 4, offset 2, 4, 5, 6, 7. So it will monotonically assign a offset to every record. Every next record, it will monotonically assign a offset to every record. It will start from 0, 1, 2, and it will go on simultaneously. I mean, go on ahead. As we are talking about, said, here is a question: can we set checkpoints in Kafka? Yes, we can. I'm not sure whether in Kafka. Usually, it is set in Zookeeper. The broker does not maintain in Kafka. Which consumer read which, how much data is not maintained by the broker. Broker does not take that responsibility. It is the consumer's responsibility. Broker never takes the responsibility. I mean, they have the developers of Kafka have decided that broker should not take the responsibility of setting the checkpoints. It is all about which consumer is consuming. It's the responsibility of the. So offsets are set on broker. And I mean, brokers sets the offset. Broker sets the offset into the file. Okay, Senthil has something to say.
No problem. Anushka options are set on broker. He's asking like options are set on broker. I said no.
Oh, it was no for that. Okay. So the reason I am taking help from Senthil is because Senthil is completely working on Kafka. Probably he has more knowledge than I have, so he can always guide on Kafka.
So Synthesis belong to Abyssop?
No, no.
Or you are just taking the training just like us?
He is a friend.
Oh, okay. Okay, fine.
So as I said, the broker is the one which, when it saves, I mean to say, internally what happens here is, if I go to this, this is my broker. This is my broker. The brokers, or I will say, so this is internally inside the broker. This is my broker, we can say, and the connection can be coming from producer or it could be coming from consumer. The producer request comes to save a data, save a record. As soon as a connection established to save a record, that request is sent to a queue. That request is sent to a queue. The IO thread will save that data to the file. I think while saving that data to the file, it will an offset, generate an offset and save it into the file. This is the IO thread. So because of these things, one producer, one broker can handle multiple partitions, thousands of partitions because of these threads. Because threads will take care of any new request comes and thread will take care of writing it to the file. So it will generate offset and it will save it in the file. The meaning is if the producer sends record 1 to broker 1, broker 1 will save it into the Apache. The way it saves is it will generate 0 as the offset, record 1. Next say the producer sent record 3. So it will say offset 1, record 3. This will be stored in a file. Next record offset 2, record 5 something if it sends record 5. So these offset will be stored. Why these offset are required? So that consumer can consume from a particular offset. A consumer can consume from a particular offset. That's the idea. That's the idea. So we have already run this program. Okay, we did not, no type, schema pass no schema. That's strange. So it was working fine. What happened to this URL? Argument 1. Did I change anything here? Oh, type. I just something. So I will rerun this program once again. So here is a question: how we will get the offset of data from the broker? Yeah, I think we will discuss. Harpreet will discuss that in the next time. The consumer side will discuss it later. Connection refused. I've received a message why the connection is refused. Okay, error server died unexpectedly. Okay, there is something problem here. I need to check this. Something happened. So let me restart it again. Let me restart this also again. Let me restart the schema registry also. Something is missing because Kafka net is wrong with this type. Comparison is fine. Let me check this. I'm not sure why this error is coming. Usually it should save the data to
I
the
think Kafka service is not running. I think Kafka service is not running Confluent.
that's what.
You could yeah, you could I mean tell me one thing. As far as I remember, I think you started the Zookeeper from Apache Kafka, not from Confluent Kafka.
Oh, is it?
Yeah, as far as I can remember, but I'm not 100% sure. So the best thing is you can fill all the process that are running right now and
Oh,
start from the scratch with Confluent.
no, it is the keys Confluent only. It is the Confluent only. So
Okay.
from the Confluent, I'm starting the Zookeeper. Zookeeper properties is fine. Did I change anything? No, I did not. After server 1, I will server 1. This is also up and running. Bin registry etc. But there is something wrong here. As soon as the schema registry starts, closing the socket of 137. The schema registry is not able to run something. Somewhere something is missing.
So I have a question raised right now.
Yeah,
If
yeah.
there is any failures like this, not only connection issue or any other issue, so there might be some detailed logging that should be stored somewhere, right? So where can we find that all the detailed logs stored in which folder that we could able to see that?
Detail logging, again, not much sure on that. Even I should look into the logging piece. I need to look into it. So I think
Okay.
this is the first error I will try to solve with the logs. Then I
Okay.
can,
Senthil, okay, okay, Pramod.
yeah.
Senthil, you have any idea on where we can check the logs if there is any failure of or if there is any errors of this Kafka services with the brokers or any others? I mean, where will these logs will be stored generally? I mean, either it can be in Confluent or either it can be in Apache Kafka. Uh, what is which directory they will go and where it will store? Because I am running some couple of applications, but I'm finding a lot of errors. I'm supposed to use Putty in my project, but it's not. I mean, the disadvantage of Putty is we can't see the proper logs. It will only show me some part of the screen. So, do you have any idea where we can check the detailed log in which directory that will be stored?
Sorry, did you ask any question?
No, he
Just
wants
Yeah, I'm asking
log.
you.
uh,
Yeah, where can you check
which log
the
you want?
I mean, any logs related to it, whether it is successful, whether it is failure, or whether is there any errors. There should be.
It depends on cluster. If you are running on the Yarn cluster, you can check it in the Yarn cluster, Yarn logs. There is one
No,
folder.
no,
Yeah.
no. Let's take it example of running it in a local machine, like a standalone Kafka service. Uh, so where does this store? I mean, where does I can see the logs?
Yeah, there will be folder called log in your local machine. It will be created inside the Kafka or outside. I'm not sure about that.
So Confluent has
Pramod, can you
log.
check it? Yeah, logs. Yeah,
Confluent
the
has
folder name called log.
Okay, for in the case of Apache Kafka.
I think for that also there will
Yeah,
be a
same.
log of
Yeah, same.
Kafka.
The folder called logs will be created.
Okay.
Usually logs are there.
Okay. Thank you.
This here we. So I need to debug that program. I don't know what is the error. It used to work. The moment it has stopped working. But I hope the session was useful. Let me debug that. What's the problem? We can have the remaining part some next weekend probably. The consumer part we'll discuss in the next weekend.
Okay. Sure, Pramod.
Yeah, I hope the
Thank
session.
you, Pramod. Nice session.
Yeah, sure, Pramod. Thanks for your time.
Yeah,
Yeah, it was a very good.
Pramod, can you share this video to all of us
yes,
for the reference?
yes. I shall upload it into the YouTube.
Thank you, Pramod.
Yeah, thanks everybody, and
Yeah.
good night.
Pramod, can I please check it out the log for you also if you have time?
Yeah, I will try that. I will try
Thanks.
that. Sure.
Please make sure it is
Thanks,
run
Pramod.
on
Bye.
cluster, Yarn cluster.
Oh, yarn cluster. Oh,
Please,
okay.
yeah, please run on a Yarn client because I already tested Yarn client. It is working fine. I want to,
Oh,
I couldn't make it into Yarn cluster.
fine. I will check. Sure, I will check that.
Okay,
Okay.
okay.
Fine. Yeah, thanks everybody,
Thanks,
and
Pramod.
have a good night and have a nice week ahead. See you.
Yeah, good night.